Hello and welcome everyone to my virtual talk. My name is Sebastian Benz and I lead the AMP developer relations team. Today I want to talk about how AMP helps you create a modern web experience. AMP is an open source web framework originally developed by Google that is now part of the OpenJS Foundation. Originally, AMP was aimed at making it easy to implement faster news articles, but over time it has evolved into something much bigger and even more useful. But before we dive in, I want to shortly talk about the web. The web is pretty great. I like the web, to be honest, and I think it's one of its unique things about the web is basically it's a truly open platform. It's probably the only one that we have. And one of the great things about it is there are no gatekeepers. Everyone can go out and publish their content on the web. And the result is there's a huge variety of content available on the web. And this makes it such a fantastic place. However, there's one problem with the web, and that is that users are often frustrated by the web. There are a few so pages load slowly, pages are unresponsive, and when you click a button, but nothing happens. And finally, this is my personal nemesis, unexpected content shifts. So basically, you've all probably seen this. So you start reading a page, and then while you're reading, an ad loads above the viewport and moves everything below. So basically, you instantly use the paragraph of where you've been reading before. So these are all common frustrations on the web that everyone has. But what has been quite difficult in the past is how can we actually measure the user experience of the page? So, and the interesting thing is beginning of May, the Chrome team introduced a new program called Web Vitals. And the goal of Web Vitals is to provide a unified guidance for quality signals that we believe are essential to delivering a great user experience on the web. And we identified a common set of signals called the core web vitals that is critical to all web experiences. And core web vitals only consist of three different metrics: largest contentful paint, first input delay, and cumulative layout shift. Now let's take a closer look at these. So largest contentful paint measures the render time of the largest content element. So image, block of text, visible within the first viewport. And this is really important to measure because, for example, in a news article, this measures how long it's going to take until you can actually start reading the article. The next one is first input delay. And first input delay measures the time from when the user interacts with the page until the time when the browser is actually able to respond to that interaction. So this is basically what measures situation. So you click on a button, how long is it going to take until the browser does something in response to this click? And the final one is cumulative layout shift. And it measures the sum of all unexpected layout shifts that occur throughout the life. And as I mentioned before, at Google, we consider these three metrics critical for the user experience on the web. And all of our tools that measure performance, such as PageSpeed, Insight, Lighthouse, or Search Console, will start measuring and surfacing these metrics. But it gets even more. So, end of May, the Google search team announced that they're going to measure how the page is experienced by a user in addition to prior signals such as the page's usefulness. And this suite of measurements is page experience. So it uses the core Web Vitals, which the Chrome team announced, and adds other pre-existing signals like mobile friendliness, safe browsing, and HTTPS security on top of it. But the question is, how does this relate to app? And we did some analysis. We saw that a majority of apps actually do pretty well against the criteria this measure. And this is not really a surprise, as these metrics line up pretty well with AMP's design goals. The goal of AMP was right from the beginning to offer its users a content-forward experience that is fast and avoids common pitfalls, such as unexpected layout shifts. But before we go into the detail on how AMP helps with building a great page experience, let's take a look at the other side of the coin. What about developer experience? I don't know if you've seen or heard this joke before. So basically, this chart depicts the time you spend when trying to use sticky tape. And as most of you probably have experienced, you only spend a little time actually taping things. You spend most of the time trying to find the end. With web development, it can be a little bit similar. So you spend only some of your time actually building new features for the users. But the big question is, a lot of the time is just spent fighting the front-end stack. And this is true. So last year, Mozilla conducted a survey among 30,000 web developers, asking them about their top frustrations. And the results are that developers found that the entire development process, from testing the code to reliably deploying their solution, to be ridden with obstacles. And as the AMP team, we try to address as many of these issues as possible. So, but first, let's take a look. What is AMP really? So, I think a pretty good summary of AMP is that it's an opinionated HTML component library for the web. And before using AMP, I often struggled with too much choice when it came to adding a new feature to a site. Having to decide whether I should build my own carousel, which is, by the way, terrible. I didn't really do this, or finding a suitable existing implementation. A lot of so the thing is, with AMP, you get a set of flexible, high-quality UI components out of the box, and you can be sure that these perform well, are accessible, play along well with it. And this really takes away a lot of the overhead of what it means to be a web developer. So what makes AMP special? The first thing I want to talk about is that it's focused on content and not on code. So AMP is a component library, and it offers more than 100 different components for all sorts of use cases. This makes it very easy to get certain functionality installed. But AMP code can look foreign and more limited than other frameworks. So it looks basically, and the thing is, all of AMP is written, and all of its content and logic is written in HTML, as opposed to maybe what you would do in a normal JavaScript framework, where most of the actual work is done in JavaScript. And this is what a typical AMP component looks like. So here's a component, the AMP YouTube component, which embeds YouTube videos. And the thing you should know about AMP components is that they are secure, fast. They are not blocking the main thread. But we're going to talk about this a little bit more later. And they are accessible out of the box. And there are components for layouts, effects, third-party content, dynamic capabilities, and many more. This example here embeds a YouTube video. So if the can recognize its declarative nature. It's basically you use an HTML element that's called AMP YouTube, and you provide additional information. In this case, the video ID. And here we use a responsive layer, which is one of the AMP built-in AMP features, which is super useful because it allows you to automatically scale the element to the available width on the device, and it's gonna resize maintaining its aspect ratio. This is like one of the built-in features of AMP, but it's not that straightforward to do this on your own simply using HTML and CSS. But this approach is really powerful. And recently I talked to a developer from an agency which uses AMP for building most of their clients' websites. And they told me that one of their design interns had been able to build a full interactive website for one of their clients without any JavaScript knowledge. And I think that's really awesome. And it's a great example for the value of a good UI component library. It makes it easy to get started for beginners and allows experienced developers to focus on creating new features instead of bike shedding technical details. So when using an HTML library like AMP, it's obviously not as flexible as one using JavaScript. There are some trade-offs, and I'm trying to depict them here in what I call a flex complex chart. So basically it shows the trade-off between flexibility against complexity. So on the left-hand side, we have AMP. So it's low on complexity, but it's also low on flexibility. And the reason for this is so it's fully managed. It's basically you can be very successful using AMP for building sites with a specific type of content. On the other hand, we have further to the right, so basically they are more flexible, but complexity increases quite a bit. We have JavaScript frameworks. So they're semi-managed, they have less guardrails, but offer more flexibility. And then furthest to the right, so offering the most flexibility, we have vanilla.js. So it's not managed, very flexible, but it can be full of traps, in particular when it comes to browser compatibility. So basically, the key to know here is with AMP, you trade in flexibility for greatly reduced complexity. And for many kinds of websites, that is exactly what you want. But on the other hand, you wouldn't want to use AMP for building the next Gmail. The next thing I want to talk about is framework updates. And I don't know about you, but I don't have too good memories about framework upgrades in the past. So there's this typical painful cycle that you have to go through. So you update all these via npm, and then basically you spend a lot of things break. You spend a lot of time on GitHub and Stack Overflow, somewhat trying to work out what is broken. That is something that is not needed at all with AMP. AMP is an error-free library. This means you always get the latest version of the framework. And for example, pages that have been published 5 years ago are automatically running on the latest AMP version without breaking, but they get the latest performance, feature, and security updates. And I think this is a fantastic thing. It makes it a lot easier to maintain an AMP site over time. So why how is this possible? So the key here is like we have a really strong infrastructure. So that allows us to create end-to-end integration tests that thoroughly check our components in isolation and in conjunction with each other. So that involves functional tests, but also UI tests. And all our tests are automated as much as possible to make sure we can run them at any time. And the third and probably most important thing is how we release AMP. So we have a tri-phase release cycle. So first, every new release goes to a canary channel. And this is basically the canary release is going to be 1 week before the main production release. And during this week, partners can opt into the canary channel and test their site against the latest release. And if they find any bugs, they report back to us. We fix it up until to the prod release 1 week later. And then recently we introduced a long-term stable release channel as well. And this basically gets updated every 4 weeks. So this is like the super stable version of AMP. I mean, there are so many more things to tell about how our AMP infrastructure and how we make sure that it stays functional, doesn't break an existing IPS and so on. Unfortunately, due to time, I can't spend much more time on this. But now let's talk about something really interesting. Let's talk about performance. So, who doesn't know this story? A bad performing site is often not caused by its developers, but by third-party integrations. So a super common scenario that I've seen many times is a site is fast on launch, but then gets slower and slower over time. So AMP is built up from the ground up to avoid this by providing guardrails for every component. One great example for this is where we optimize performance on page load is AMP's static layout system. So before any media or other assets are loaded, AMP already understands the final layout of the page. So it knows exactly how much space each element on the page is going to take. So it also knows which elements are going to appear in the first viewport. And these are the elements that are super critical. For example, images in the first viewport should be loaded as quickly as possible, so it can higher prioritize loading these. And it can deprioritize loading images further down to really basically only pull in the content that's really not needed for the first viewport. The other really great side effect of this, that this avoids content jumps by design. And this is a great improvement for user experience and pretty hard to get right if you have to manage this on your own. And if you remember before where I mentioned the core web vitals, the cumulative layout shift metric, that's not a problem for AMP size. There we perform usually extremely well. Another thing is, or an important thing to know is AMP can only manage your overall performance when it knows what's going on and nothing interferes. So key here is that all third-party scripts and iframes are sandbox. So this really ensures that an app script or an analytics script doesn't go crazy and slow down the overall performance of your page. However, this also means that you can't just write your own hundreds and hundreds of lines of main thread blocking JavaScript and put it into an AMP page. So, and that's a really scary word here. So main thread blocking JavaScript. So what does this really mean? So for a typical website, all user interaction, layout painting, and execution of JavaScript happens on a single thread, the main thread. And when that thread is busy, nothing else can happen. So if some expensive JavaScript calculation is run in the background and the user tries to scroll the page at the same time, nothing happens until after the JS execution has been completed. And that's a really terrible experience. But of course, it's possible on a website to work around this problem. And what you can do is splitting up the work on the main thread into many small micro tasks. And then do work in the moments when no user interactions needs to happen. And bigger chunks of work, you can move them into something called web workers, who run on a separate thread, and basically when they're finished running, they pass the result back to the main thread. But that's something that isn't done often in practice. And one of the reasons is that this is quite complicated and hard to maintain over time. And a really nice feature of AMP is basically that it manages all of this for you. So AMP components that are somehow computational intensive, by default, they will all offload all the work into web workers. But you can also do the same thing for custom work. And this is really one of the coolest and unique features of AMP. That is, it's super simple to implement workerized JavaScript. So what we have is a component called AmpScript. And that allows you to write completely custom JavaScript. And that's needed for these cases where AMP might not be flexible enough to suit your needs. And the best thing about this, so you can write your own JavaScript, but it will be automatically run in a web worker, so it doesn't compromise the performance and overall user experience. So the key here is what we said earlier about the main thread. AMP scripts run off the main thread in a dedicated web worker, but the great thing here is it simulates the DOM APIs. And so basically you can create elements and basically work as you would on the main thread, but you won't affect the performance of the main thread. And key here is AMP still controls the main thread, ensures that users always have a great experience. And this enables some really cool features. So you can, for example, run frameworks like Preact inside an AMP script to render the UI. But you can be sure to not impact the performance because everything is running in the worker. And as a developer, basically, this means you get the best of both worlds. You get the JavaScript and the DOM you're used to, but at the same time, you get the ease of mind that you won't have to worry about causing performance issues. And if we take a look at the graph before, this also means a great shift in AMP's flexibility, because now it's not only possible to use the existing components, but you can build your own functionality using AmpScript, but key areas without increasing complexity or compromising user experience. Next thing I want to talk about is basically where you can use AMP. So in general, it's a web framework. It works in most browsers. It works across mobile, desktop, and tablets. But in fact, there are a few things that make AMPs really useful or really great at building responsive designs. For example, there is an AMP layout component that implements common layout patterns. It's like responsive, intrinsic, fill, and so on, that are non-trivial to implement on the web in a cross-browser compatible manner. But here it's just available out of the box. Another really nice feature is element level media queries. So this makes it really easy to adjust the content on your page to the user's devices. And finally, and this is very exciting, so if you've invested into AMP, many more opportunities open up. Thing is, when we realized that AMP works really well in making it easy to build fast websites, we thought that maybe this could also be used for other types of content. And the reason why it could be useful for other types of content is basically are the unique characteristics of AMP. So it's an HTML component framework that works without JavaScript. And this means, for example, nowadays, if you know how to build an AMP website, you can also start building ads, emails, and visual stories with AMP. For example, emails is an extremely great use case for AMP. So I don't know if you've ever had to build a dynamic email using HTML or CSS, but that's a science by itself. And the reason why there's no JavaScript allowed inside emails is obviously security and privacy. But with AMP, you get a powerful framework, but that works without JavaScript. So you don't have to compromise on security and privacy. And basically, this is what AMP for emails is. Basically, you can build truly dynamic emails, and it's available on different email clients such as Gmail or Microsoft Outlook. And for example, one of my favorite features is I spend a lot of time in Google Docs. And whenever a person comments on one of my docs, I get an email informing me about the comment. But then I can directly reply to the comment inside the email, inside my email client. And this is a massive time saver for me. Another really thing I mentioned before is our stories. So basically stories that are visual web stories that enable you to build Instagram or Snapchat-like experiences for the web in a truly open manner. And that's a really exciting new way to create content for the web. Now let's talk a little bit about caching and distribution. So funnily, so the original name for AMP wasn't AMP, but it was Portable Content Units. So the thing is, it's just not only a fast by default web component framework. So the pages that you build with AMP become what we call portable content units. So that is content that can be safely pre-rendered on a platform that supports it, such as Google Search or Bing. And this works because of two critical building blocks: Prerender Mode and AMP caches. So Prerender Mode means so you can load an AMP page in Prerender Mode and it won't fire any analytics requests, image requests, and so on, to avoid, for example, that the page leaks any kind of user private information on while pre-rendering. And the other thing is the RM caches, and these are optimized distributed delivery mechanisms for the AMP pages. And putting this together allows platforms such as Google Search to provide an impossible fast, often instant experience. So for example, in search results, the results page can preload and pre-render an AMP page in a hidden iframe. And then when the user clicks on a result, it's instantly there. And because of AMP's pre-rendering mode, this happens in a privacy-preserving manner. I think this is really a fantastic user experience enabled by AMP. And finally, I want to talk about PWACE. So PWACE and AMP, basically, it's two different things that work really well together. So if you invested in AMP, it's possible and often very easy to turn your AMP site into a PWA. So they are not orthogonal, they are orthogonal and play really nicely together. And one of the key features here is the AMP one-line service worker. So service workers are one of the key features of PWAs, namely things like offline support, caching, and so on. And basically, an AMP provides a one-line service worker that's super easy to integrate and install, and that provides AMP-specific functionality out of the box, such as offline or network resiliency. So this means, for example, that if the user is on a really slow connection, the service worker is not going to fetch latest content from the backend, but serves users cache resources instead. But if the user is on a fast connection, it's going to always try download the freshest content. So this brings us towards the end of my talk. So AMP is an opinionated HTML components library, and it's because it's only HTML, it's really easy to get started. So building a web page with AMP really feels like web development from 20 years ago. So you use HTML and CSS. But it's not only easy to build, you can greatly reduce your iteration costs. And one of the key benefits is you have zero long-term maintenance costs. And that is really, for me personally, one of the biggest benefits of AMP. It's just that long-term productivity really improves by using AMP because maintenance gets a lot easier. And the last thing is, I talked at the beginning about that we're now finally able to effectively measure a good user experience on the web. And that basically this enables new use cases, such as basically, for example, better being able to surface pages in Google search results with a great user experience. And with AMP, there is a really easy path for building sites with a great page experience. So thanks a lot for listening. And if you want to learn more about AMP, please visit amp.dev. And otherwise, I'm happy to answer any questions.
Thank you very much, Sebastian. It was really good. If the audience was here, we would clap. It would be a big shout out. I'm sorry that it's online. I'm looking at Slido, and we don't have yet any questions on Slido, but please reach out to Sebastian or write a question right now on Slido so we can answer that here. If you're not comfortable with asking questions online, you can go and talk to Sebastian directly in the speakers corner. Sebastian will be there for 15 minutes, and you will find the speakers corner right at the next to the spawn point when you enter the 3D world if you're not already there. So note that if you want to go to speakers corner and you're watching this on YouTube, you need to go to the 3D world of mdevcamp. And I'm looking at the slide. You still no questions. It's up to you, Sebastian, if you want to wait a couple more minutes because it was faster than we expected. Refreshing. No. Well, never mind. AMP is really current topic and very interesting. We held like a month or two right before pandemic. We had a great workshop on AMP, so I highly recommend to anyone interested or not acknowledged yet with this topic to dive more into it. And definitely, I'm not going to hold you here any more longer. If we don't have any questions on Slido, I'll ask you to go to the 3D world, to the speakers corner, and I encourage everyone to go and talk to Sebastian. And we will have a short break, and our next speaker will come at 3 p.m. Wow, Sebastian, you were really quick. So we got like half an hour.
Sorry about that.
No, don't be sorry. That means you were on a point. So thank you very much, Sebastian. We'll see you in the speakers corner and hopefully somewhere in the 3D world today and tomorrow. And everybody else, thank you very much. I'll see you shortly. And don't forget to tweet with the hashtag mdevcamp.